Welcome back, welcome back, everyone. I hope you all had a refreshing break and are ready for the next set of enriching technical discussion.
Let me take a moment to introduce our distinguished speaker, Dr. Sucharita Pradhan ma'am, who is a leading expert in the integration of RS and GIS for watershed planning and management. Her work emphasizes sustainable water resource development and environmental conservation using geospatial tools.
Now, I would like to brief about topic remote sensing and GIS are powerful tools for watershed planning and management. RS provides spatial data on land use, vegetation, and hydrology, while GS integrates and analyzes this data to model water resource, identify vulnerable areas, and develop sustainable strategies for flood control, soil conservation, and water quality improvement.
To kickstart this session, I invite Dr. Sucharita Pradhan ma'am to present on the topic applications of RS and GIS in watershed planning and management. Please join me in welcoming her with a huge round of applause.
Thank you so much. A very good morning to all of you. In this lecture, we learn about how we can use remote sensing and GIS in watershed management. This will be a combination of theory and practical classes. First of all, we'll see how we can use it, and then we'll done some exercise, hands-on exercise. Okay. Let me share my screen with you. So is it visible?
Yes, ma'am.
Okay. So So, as we know, there are two key resources of watershed management. First is soil, and another one is water. So, whenever we study about different aspect of soil, we call it land resource inventory. And whenever we study the movement of water and different aspect of water in the air or in the soil, we call it hydrological analysis. So in land resource inventory, it contains a detailed database of natural resources, that may be your land resource or water resources, their inherent potential, constraint, status, and their changing condition of all parameter. It may be your land use, soil, then what is the water, how the river is flowing, how it is bending with respect to time. All these resources we collect it and we store it in the resource inventory. So basically the information on land use, soil depth, what is the texture, surface texture, subsurface texture, then what is the gravel percentage of a area, then drainage capability of that land, erosion status of a particular land, and flooding status. These are the database we collect in land resource inventory. So in watershed management activity, we divide into three parts. First is pre-field activity, then field activities, and the post-field activities. So in pre-field activities, what we do, we collect the data, available data, whichever is available with us from different sources. It may be your satellite image, it may be your digital elevation map, or any information on geology, watershed boundary, or anything like your whatever data existing. We first collect it, then we analyze it, we interpret the image. Okay, so the satellite data may be of different type. Maybe if you are using for a smaller area, you need in a very good way, so you may need high resolution data of your, or if your area is of higher area, means you are analyzing in country scale or in state scale, you may go for low resolution data. It may be 30 meter or 100 meter or 200 meter, or it may be 1 meter by 1 meter. So it depends upon your requirement. Similarly for digital elevation model also, for elevation data also, elevation data are available in many resolution, like from 0.5 meter to 1 meter to 5 meter, 30 meter, 90 meter, depends upon your requirement. You collect the data and then you interpret it. Okay, then we delineate the area. Suppose, how we'll delineate, suppose we do not have a watershed boundary. Okay, so what we do, we first delineate it from the digital elevation map. Okay, so in digital elevation map, based on the elevation and contour line or slope, we delineate the boundary of the watershed. There are different kind of delineation also. Suppose you have three number of different maps, like geology, landform, or slope. For example, you want to study a area based on these three information. It may be of any number. Suppose there are 10 number of or n number of information you have, and based on those information you have to analyze a area. So what you will do, you will go to each one of the map, then we'll again come to the whatever study you are doing. Suppose I am doing groundwater study, so I need geology, geomorphology, then slope, what is the lineament, and what is the drainage capability of that area, what are the rocks available. These data I need for groundwater analysis, right? What is the aquifer parameter, what is specific yield, like hydraulic conductivity, all this information I need. So what I will do, I will create a map based on all this 10 information. Okay. So based on that one map, I will analyze my groundwater potential of that area. So that is what we do in delineation part. So in pre-field, before going to the field, we first analyze those data. We created a map. We create some grid point. What is grid point? Grid point be of any dimension. Like for example, you can see, you can observe here that these are the grid point. Is my screen visible?
Yes, ma'am. It's visible.
Okay, okay, okay. So you can see these are some grid point. I have taken it like 10 meter by 10 meter grid. So I have to collect sample from each 10 meter. Okay, each 10 meter of grid, I have to take one sample. So you can create it by 100 meter by 100 meter depending upon your requirement. So before going to the field, we created this grid map. We put those point from where we want to take sample. Then based on this study, we go to the field. Okay. In watershed management, what we do, we go to the field. Then what we'll do in the on the field, once we are on the field, we check the accuracy of our image interpretation that we have done in our lab. Okay, suppose we are the satellite map is of 2 3 years back. We are in 2024. The satellite image that is available with us is of 2020. So what we'll do, we'll rectify whether that land use land cover or the satellite image is matching with our ground condition or not. Okay, so that is the accuracy, checking the accuracy of a image interpretation. Then we locate those grid point. Suppose I have taken a grid in a particular area, but when I arrive at that point, I have observed that there is a pond constructed on that area. So can I take the point? Can I take a consider that a grid point? No, I have to move to a different location. So I will shift my grid point, or I will shift my point within that grid but to a different location. Okay, then I will take the coordinate of that point, because while analyzing in GIS, coordinate is the main thing. Without coordinate you cannot do any mapping, we cannot do any analysis. So first of all, I will take the coordinate of that point. Then I will collect all this information, like whatever data I need. It may be soil depth, soil texture, graveliness, what is the present land use of that area. All this information I will collect from that area, and I will come back to my lab. Okay, so again, when I come back to my lab, I will interpret whatever sample I have collected from the field, then generate from that data. I will generate the thematic map using GIS. Okay, so these are the activity in watershed management. So we'll see what are the different hydrological activity that we have to do for watershed management. So first of all, we have to collect data. It may be from a different instrument, different satellite image. Satellite image is very much helpful where the area is very much inaccessible. We cannot go there, so we can use the available satellite information. But if the area is feasible, you can go to that place. Then, or you can install some instrument over there. Then it's better to go for instrumentation on the study area. Then we'll study the stream part. What are the streams available? If the dam data is available from the slope, we can generate stream network. Or if it's not available, we can generate the stream network from the Google Earth itself. In the hands-on session, we'll see how we can generate the stream data from Google Earth. Okay. So we generate the stream data from suppose from a uh, toposite map, or from Google Earth, or from satellite images. Whatever data we are generating, we have to ground truth it, ground verify it. Okay. Then analysis of climate, historical climate data. Then water balance simulation. There are models available, freely available, open source model are available. One is SWOT, soil and water assessment tool, where we can analyze the water balance component. And based on the water balance component, we can position our soil and water conservation structure. So soil, it may be your check dam, or maybe your loose boulder check dams, or a masonry check dam, or any gabion structure, or any soil conservation part like trench comb bond or a field bond. It may be a graded bond, anything it can be. So based on those water balance simulation, we have to position it. Then whatever activity we have done by our research, we have to go to the field for community consultation. Community consultation means what are the opinion of the community that is living there. So based on their opinion, suppose we are planning to construct a water harvesting structure on a farmer's field, or near to a riverbed or river or something, but the community is not allowing us. So we have to shift our point. We have to revise our suggestions. Okay. Then after the our plan and estimate is finalized, we go for the design. of the soil conservation structure for a particular area based on the data that we have collected from the field and from satellite images, anything. Okay. And other aspect are groundwater potential joining, that can be done in GIS platform. Then quantification of available groundwater resources, and based on those data we can go for water budgeting, considering both the surface water and groundwater, and we can choose the management practices. Okay, so these are the different hydrological activities for watershed management where we use remote sensing and GIS. As you can see for groundwater, this is our study area. So for groundwater, we have installed automatic water level recorder, which is providing us in hourly basis, and also we have water level indicator that is manually operated. Uh, it is They are taking the data in weekly basis, and we have installed some automatic weather station also. In weather station, all the weather parameter like rainfall to soil moisture, then air humidity, air temperature, everything it is providing us. For evaporation, you can go for class A evaporimeter, which you have to take the data on daily basis. Then we have to monitor the soil moisture, surface soil moisture, and also the for crop. Normally we are taking profile soil moisture. So we are using TDR, the time domain refractometry. So this data you have to collect. For water level recorder, to record the monitor the water level of a river, we have installed automatic stage level recorder, and also by velocity data using a current meter. And in remote sensing part, we are using world view data, because all this data information we are analyzing in a very high resolution. It is of the world view satellite data is of 1.8-meter resolution. So all this information we are using for our water balance simulation. Then this is a stream network that we have delineated from Google Earth or satellite image. You can go for satellite image also, or you can go for digital elevation model also. So this is a stream network. You can see this is a first order stream network. Then it becomes the second order. When two second order stream join together, it becomes the third order also. So this analysis we have done in the Google Earth platform. Then we take this data to the field. Okay, then we verified. As you can see in the picture, they are verifying whether the stream are existing on that particular location, whether it is flowing on that particular path, or it is flowing with time. It has the direction is changed over time. All this information we ground truth it. Okay, so after that we finalize the map. So we learn how to in the hands-on session we learn how to create a beautiful map like this. This is the stream network of a micro watershed after ground truthing. Okay. So in watershed management, we also analyze historical climate data, like annual rainfall, what is the normal rainfall of a particular area, deviation of rainfall from normal, or what is the monthly distribution, then the frequency of rainfall. You can go for length of growing period. In the length of growing period, we go for the soil moisture also. What is the moisture availability in different period of time? Then by using those data like digital elevation, land use, in soil type, what is the hydrologic classes of the soil, then what is the hydraulic conductivity, graveliness, texture of that particular soil, then weather data. All this information we fed into soil and water assessment tool, that is the SWOT model. Then we go for simulation and calibration of that model. And for calibration, we have used the observed stream flow data or evaporation data of that particular area. Then we generate the water balance component. In water balance component, mainly we focus on runoff, evapotranspiration, deep percolation, soil moisture, what is the water yield, and the sediment yield of a watershed. So you can see these are the different parameter after the simulation of so you can see the sediment yield is quite, which means that there is a need of soil and water conservation structure which will reduce the sediment yield. If you can see, the surface runoff is around 23% of the rainfall. So by using some by water harvesting structure or soil and water conservation structure, we can reduce the runoff. We can only allow the environmental flow. Then other thing we can conserve in our watershed. So all this information we generated from the remote sensing data. Some we have collected, and all these analysis are done in a GIS platform. Okay, so how we can position the soil and water conservation structure, and how we can form a map of that structure. Suppose I have few criteria. I will look into what is the slope percentage of my area, what is the texture of what is the soil texture or subsurface texture, then the soil depth or landform. So landform is of different type, like the hilltop, hillside, foothill of that area, then upland, plain, and valley. So based on the landform, I have to suggest the treatment. So for non-arable area, these are the treatment. If the slope is greater than 25%, then we can only suggest for plantation. Likewise, if it is less than 5%, we can go for field bonding or graded bonding. Likewise, in arable land also, if the slope is 3 to 5% and the texture is silty loam or clay loam, sandy clay, and it is in plain area, then we can go for unlined on-farm reservoir or water harvesting structure. However, if the texture is of sandy soil or sandy loam, then we can go for lined OFR. So this decision we have to take based on our data. Then what we do, this treatment, based on this treatment, we create a map. Okay. So this is the soil and water conservation plan of a micro watershed. As you can see, this is a hilly area. So we have suggested hilly area, but the slope is around less than 5% slope. So we have suggested field bonding. Field bonding means it will be a graded kind of bond, which will channelize the runoff to a particular or nearby water harvesting structure. So these blue area, these are the valley. So we have suggested integrated farming system ponds, where the farmers can harvest water and they can utilize those water in cultivation practices. Okay, so in no intervention, you can see these area, red color area, we have suggested no intervention. Why no intervention? Because it is coming under habitation class. Okay, similarly the trench compound. For trench compound, you can see if it is less than in upland area, if the slope is less than 5% and the soil depth is less than 100 meter, okay, 100 centimeter, then we have suggested trench compound. Similarly, if it is plain area, the landform change to plain, then in 1 to 3% slope we can go for trench compound. Okay, so based on this filter, we have suggested the soil and water conservation plan. Then coming to this all about soil conservation or water conservation. But what about the channel? What about the channel drainage line of a watershed? So there also you have to look into different parameter. In our study, we have taken the what is the stream order, what is the length of the stream, then stream alignment, and based on these three parameter, we have suggested the structure. So for fast order stream, if the length is less than 200 meter and the alignment is very much straight, then we can go for broadwood or vegetative check dam or percolation tank if sufficient depression is present. Okay. So for second order stream, if the length is less than 200 meter, then we can suggest we can go for loose border check dams, or the length if the length is greater than 200 meter, you can go for gabion structure also. So for third order stream, we can go for masonry check dam. But for masonry check dam, the main criteria is the stream alignment should be very much straight. There should be no meandering. Okay, so if there is meandering, then there is a risk of construction of masonry check dam. Okay, these things. And there is a second thing, there should be agricultural land near to the masonry check dam, so that whatever water is harvested by the check dam, we can irrigate it to the nearby area. Okay, so for percolation tank, what is percolation tank? It's like a water harvesting structure, but constructed near a hilly area, or mostly in the foothill of a area. So first of all, the stream suitability is first order or second order stream. And how we can identify whether it is first order or second order stream? From the Google Earth images or from your stream network that you have generated from the digital elevation data. Okay. So once you get the stream order, if it is first order or second order, then you go for the site selection, which site will be very much suitable. So if there is sufficient catchment area, at least 10-hectare land, and it is coming in the foothill and sufficient depression is present and it can irrigate to the nearby area, then we can suggest a percolation tank. Then coming to the volume of that percolation tank, how we can do? We have to uh, generate the delineate the catchment area of that particular percolation tank. Whatever catchment area we have delineated by using GIS, then we multiply with the depth of runoff. Depth of runoff from that soil phase or soil information, we have to generate the depth of runoff. And runoff can be estimated by SWOT model, soil and water assessment tool. By simulation of that model, you can generate the runoff. You multiply with the catchment area, you will get the storage volume. So based on that storage volume, you have to construct the percolation tank. So that is the use of GIS and remote sensing. Okay. For example, you can see this is a picture of Google Earth image. As you can see, the red line is our watershed boundary, and we have suggest to construct a percolation dam here. Okay, this point. Why this point? Because it is coming in the foothill area in the second order stream, and near to that there is so much agricultural land which can be irrigated by the conserved water. Okay. You can also check the elevation of that particular point. Suppose it is also, we will do it on the Google Earth platform. You can see this is the highest depression, like 258 near to 250 to 60-meter depression is there, elevation is there in that point. So this is the most suitable point to construct a percolation tank. And based on that, this is the drainage line treatment map. This map is also created on the GIS platform, where you can identify in which stream we have suggested brushwood check dam, loose boulder check dam, or this green point is masonry check dam. This red one is percolation tank. So everything you can locate it on a map based on those data and analysis. Okay. After the analysis is done, we again went to the field for community consultation. What community wants from us? Because all our study, if it is not applicable to field, then it all our you know it's in vain. Okay, all our effort is in vain. You know, that's why always go for community consultation. What the community wants, what is their demand, what is their suggestion based on their experience of that area. We show this map to the community and make them understand that this is where we want to construct a pond, or this is where we want to construct a masonry check dam, and this will be our this is the water requirement of your area, and this much water will be harvested which you can use for your cultivation. We try to convince them. Okay. And we get the suggestion from them also, and based on the suggestion, we again go for the revision of our plan. For example, you can see these are the this yellow dot are the location of percolation tank and masonry check dam before community consultation. But the green point, grid point, these are the suggestion of water harvesting percolation tank or MCD after we done the community consultation. So based on the feasibility of their suggestion, suppose they are suggesting to construct a pond in a very hilly area or rocky area where the graveliness percentage is higher than 50% or 60%. So obviously we cannot go for it. Okay, if we will construct by avoiding the science part, or if it is against whatever analysis we have done, whatever research we have done, then we avoid it. But if it is coming in the zone of our science, Then we accept their suggestion and we revise the hydrological plan according to that. So this is also a revision of our hydrological plan after community consultation. This is the soil and water conservation plan map of Rengalbada Dondasinga micro watershed. It's coming under Barcode block. Suggested area, if he is or she is agreeing to construct a farm pond or any structure, we allow it, we consider it for revision of our hydrological plan. Okay. Then another part is groundwater potential zoning, or what is the groundwater potential or status of that area. So in this groundwater potential zoning, we have considered six parameter, that is the geomorphology, soil texture, land use, land cover, lineament density, drainage density of that area, and slope. So these are the very easily available data that you can consider for your research part also. All the PG student who are working on GIS and remote sensing, they can adopt it also. But if you have other data like aquifer parameter or specific yield, and permeability, then you can use those data for your analysis. So what we do, we first delineate those six parameters, six data, then we classify it. So we have used analytical hierarchy process. So analytical hierarchy process, why we have used it? Because we can give weightage to a map, higher weightage to a particular data, uh, and we can you give lower weightage to a particular data which is of uh, low importance. Suppose for groundwater, the lineament density or the drainage density is very much important. So we keep it on a higher weightage scale. And for slope or for example, land use, land cover, it is of lower importance. So we give a lower weightage to that particular map. So all these operation we have done in the GIS platform. Then we generate the groundwater potential.
Excuse me, ma'am.
Yes.
Ma'am, your slide is stuck. Please reshare your screen once more.
Okay. 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 Is it visible now?
No, ma'am. Ma'am, you can share entire screen.
Is it visible?
No, ma'am. Again, it's not visible.
Yes, ma'am, visible.
Visible. Okay. Okay. So this operation, now it is okay, right?
Mhm.
Shall I continue?
Ma'am, please wait. We are checking it.
Okay. Okay. Just let me know.
Yes, ma'am. It's visible now. You can continue.
Okay. 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 So all this operation where we are giving weightage to different parameter, higher weightage to some and lower weightage to few of the data, that analysis also we can done by using a GIS. And this is very much important for the graduate students also. We are who are learning it in the basics. These are the basics of remote sensing and GIS application. Okay, so this is our groundwater potential map. We have considered all these six parameter and created a very nice groundwater potential zone. Again, you have to validate it on the field, whether suppose these blue zones are coming under very good groundwater potential zone, but you have to validate it on the field whether actual scenario is existing or not. So you can see it from the groundwater data that you are collecting, or there are some agency, district agency, or CGWB, Central Groundwater Board also there. They are also collecting groundwater data. Then all these map have to be verified on the ground. Okay, so we have linked the groundwater potential zone to the cadastral map. And what is a cadastral map? These are the plot. You can see these are the this red boundary, sorry, black boundary are the plot boundary of that area. So suppose this area, this particular area is coming under very good soil water groundwater potential zone. So the farmers can construct a borewell or dug well on that particular on their particular farm. But if you consider this yellow zone, it is coming under moderate. So the farmer of this zone, they have to think about it, whether they can go for they have to take the risk, or they have to go for construction of borewell or not. So these are the map that will be helpful for taking a decision. Okay. So after all these are finalized, we design it, then we estimate what is the cost of our plan. We estimate it, then we execute it on the field. So these are few of the execution we have done in our project. As you can see, these are the brochure check dam. We have strengthened the field bond of that area to store the runoff water and to increase the soil moisture of that particular area. These are the trench comb bond constructed on the forest area, or like open forest or shrubland, where the runoff water can be stored and the soil moisture of the lower area can be enhanced. This is the IFS pond, loose boulder check dam. This is the Gabion check dam constructed on the stream. And this is the percolation tank that is constructed on the foothill of a area. So this type of work we can do by using remote sensing in GIS. Okay. So again, uh, that is not the end. We have to see the projected scenario. What will be the how our parameter, hydrological parameter, will be changed after we go for the watershed treatment. So what is the percentage of decrease in runoff, or how the soil moisture is increasing, or the depercolation is increasing, whether the sediment yield is reducing or not. We have to check also. We have to project it. We have to verify it on the field. Okay. So this is all about the application of remote sensing and GIS on in watershed management. So we'll few things we'll learn. I have shared few data with you. Um, Komal ma'am, uh, do you have the data?
Yes, yes, we have already shared.
Okay, okay. So first of all, we'll learn. These are the practical we'll do in this class. First is importing field data to a map environment. First, we'll understand why we'll do it, why it is necessary. Because suppose you are taking some information on groundwater, for example. So you have the coordinate of that point where we are taking the observation groundwater data from a observation well or any open well. So that particular coordinate or location, you have to import it to a map environment. Okay. So that is first we'll create grid point creation from coordinate. From those coordinate, we'll create some grid point, and we'll join it again. We'll join it to a field data. Suppose we you have created a grid point in 2024, but you are taking continuous groundwater data till 2050. So how you will link the data of 2024 to 2050? That will also we'll learn. Okay. Then the next stage, geoprocessing operation. In geoprocessing operation, there are few like clip, intersect, union, or merge. We'll learn few like clip. What is clip? Suppose you have a big area, but you don't have to analyze for all watershed. You have to only know the data or data of a particular block or sub watershed or micro watershed. So you have to clip it from the original data. Okay. For why we'll use intersect or union? Suppose you have two district, nearby district, but the data set are different in different zip file or in different data. So you have to join it. So you will go for union. And where intersect, if you have a district data or population, and again you have a district wise data, district wise data of those population who are literate. So what you will do, you will intersect it, and you will get the population data who are literate. Okay, in likewise we have to do the geoprocessing operation. Okay, so you may open your ArcGIS environment. Okay, so this is our groundwater data. Okay, okay, is my screen visible?
Yes, ma'am.
Okay, so this is our groundwater data. So what we have ID, site details of that particular area, its coordinate, longitude and latitude, and the uh, groundwater of 1991. Okay, so we have to, this data is in our table format or Excel format. We have to take it to our map environment. So how we'll do it? Okay, so you open your arc map environment, you go to the file. Okay, then you go to the add data. Please let me know if you want me to slow down. Okay.
Yes.
Okay, ma'am.
Now it's fine. Huh?
Yeah, you go to your file, then click on add data and click on XY data. Why XY data? Because it's in XY, like X coordinate and Y coordinate data. You click on XY data, then here a pop-up window will open and it will ask to choose a table from the map or browse from another table. So we have to insert the table in this window. So select this browse option. Okay. So now you have to navigate to your folder. How you will navigate? So there is an option connect to folder. Okay. Is it coming? Yeah. Okay. So is the folder is connected? Is it coming?
Ah, it's coming. Yes.
Okay. So here you have to connect to the folder. You click on that folder.
सबका ओपन हुआ है ना वेट करने के लिए बोले बताओ
Okay, I'm repeating again. You click on this connect to folder option.
hello Dr. Sucharita, actually some of our students still have not extracted your
Okay.
data file, so they will take just
Okay, no
5
problem.
minutes.
Just let me know.
Yes, sure.
Okay.
Hello, Dr. Sucharita.
Yes.
One more thing.
Okay.
Actually, two coordinate systems are there now, PCS and GCS.
Yes.
Yeah, I want you to explain these things. Actually, students are
Okay.
not aware about this. What does
Okay.
this ordinates represent?
Okay. 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 No problem. So I can show you something. Uh, what is GCS?
Just
GCS is
brief
geographic coordinate.
introduction, not in detail.
Okay, I will give a brief about the GCS and PCS. GCS is geographical coordinate system. So in GCS, what we do, where the point is located on Earth. So the globe on the globe where the point is located, that is the GCS coordinate system. But if you see, if you flatten the globe, okay, if you flatten the globe, where the location, where is the point location, that is PCS. I can show you some image. I think I have. Okay. Yes. See, is it visible?
Yeah, it's fine, huh?
Yes. So this is GCS on the globe where it is located. This is the GCS coordinate system. But if you flatten the globe, what is the location of a particular point? That is our PCS, projected coordinate system. So in projected coordinate system, there are various type of coordinate system like UTM. We generally follow the UTM coordinate system. I will give an introduction of UTM also. Okay. This is our UTM coordinate system. When we flatten the globe, uh, this UTM coordinate system divide the Earth, complete Earth to 66 zone. Okay. So all six zones, 66 zones are aparted by 6 degree. So if you can see, the India is located between 42 to 47, UTM zone 42 to 47. Like this, there are different other projected coordinate system also. We'll see it when we create map. We'll learn about it. But this UTM system, projected coordinate system, we'll use it in our mapping environment. So India is located between 42 to 47. So if you see Jharkhand area, then yeah. So we can see this is UTM zone 45. But if you go to Chhattisgarh, there is UTM zone 44. If you go to the north, it is 43. And if you go to the northeast direction, it is 47 and 46. And based on this number or zone number, we have to select it. Okay, this is the projected coordinate system where we open the like our globe to a flat surface, and the unit is in meter, kilometer, like linear unit. However, in geographical coordinate system, it is in degree decimal unit. Okay, so this you can see, this is the world UTM zone from zone 1 to 60.
Now we can proceed to our hands on. Yeah, that part.
Okay, okay. So just click on this browse option. Go to, okay, I will repeat it from
One more question is that.
yeah,
Huh, please repeat it once again. Huh?
I will repeat it. So go to your file. I will show the data first, whatever data we have. So just open the groundwater data. Okay, so we have two sheet 1 and sheet 2. In sheet 1, we have ID, site detail, longitude and latitude, and the groundwater data of 1991. Okay, so we'll import this data, this table data to our map environment, and then what we'll do, we create a safe file, okay, a vector file of that area, that point. Then second thing what we'll do, on the sheet 2, you can see there is groundwater data of year 2013, and there is a fluctuation also. So what we'll do, after creating a safe file, we'll link that save file or point data that is on our map to this table. Okay, so what does that mean, how it can be helpful? Because if you have taken the data of 2024 and you have created a save file today, you can link that save file to uh, your data of 2050. Okay, continuously we are taking the observation, and then you can relate it, you can connect to it, so you don't have to create the save file again and again. Okay, so first of all, we'll import this data sheet 1 to our map environment. So just open your ArcMap, then go to your file, then select add data, and then go to your add XY data. XY data mean X coordinate and Y coordinate data. Just click on it. Then this window will pop up. So click on this
One minute, please. Actually, in
okay.
one of our student system, I can see that coordinate system of input coordinates. In that place is showing unknown coordinate system in place of that WGS and CGS.
No problem, no issue. No issue. Actually, my art map is already open. That's why I have done some analysis before, and that's why the description is
Okay, okay,
coming
okay.
like this. But if it is unknown, not a problem. We'll give the coordinate system and the input coordinate. Not a
Do we
problem.
need to specify this UTM zone 45,
Yes, no,
45 and once again?
yes, we will give the coordinate system to our data. Okay, let me open it once again. Then you can
Okay, okay.
relate it. It will take few seconds.
हाँ हाँ इसमें से सेलेक्ट करना हाँ हाँ वही वही एक बार देखेंगे जिससे इसमें जाओ
Okay.
जब
So I will start from the beginning. I'll go to my file, add data, add XY data. So this is what you are asking, unknown coordinate system. So it's not a problem. We'll give a coordinate system to our data. Okay. So first of all, we'll choose a table from our data set. So click on this browse option. Then this add window will pop up. So from this add window, you can see from here also you can navigate, but it will show only the connected folders. Okay, so I have connected my folder, required folder. However, if you in your system, what you have to do, you have to connect your folder where you have saved the data. So click on this connect to folder option. Okay, this one. Then navigate to your folder. So I have saved my data on process B drive, and you select your particular folder, and I have saved in bits Hindri. So I will click OK. Once you navigate to your folder, click OK. Okay. Okay. So it will show the folder inside it. So I have selected Hanson session, then bit, then there is a groundwater XLS. Okay. Another thing I want to mention, you have to save the Excel sheet in a particular format. It may be your CSV or .xls file. Okay. If you have saved in other format, the version of your ArcMark may not able to read it. So always remember, if it is not taking the data, save it to CSV format or XLS format. Okay. So I will select the groundwater.xls file. Then I will click on add. Okay. Then it will ask to select which sheet. So we have data on our sheet 1. So first of all, we'll select sheet 1. Later on, we may use sheet 2, but for this operation, this practice session, we'll use sheet 1. So select sheet 1, click on add. Okay. So then everyone is on the same platform.
Yes, ma'am.
Yes, yes, sir.
Okay. So you have to select the x coordinate and y coordinate. So what is x coordinate? Will it be your longitude or latitude? Can anybody tell me what will be your x coordinate? What I should choose? Is it longitude? Yes, longitude, because longitude is varying in x direction, right? And latitude is varying in y direction. So in x field, I will choose longitude, and in y field, I will choose latitude.
Latitude, yes.
Okay. I do not have a z value, so I will keep it to none. Okay. So the next is the coordinate system. We have to give a coordinate system to this data. So if you can see, what we'll do, we'll provide a geographic coordinate system because want to position the data on our globe. So where the point is located, that we have to define. So here we'll use geographical coordinate system. Okay. So you go to your edit. Okay. So here you select the geographic coordinate system. Click on this plus sign. Okay. Then go to your world. Okay. Then go to your WGS 1984. And this is a datum system, World Geodetic System. WGS 1984 is a datum that you are using. So from that datum, what is the position of our point? Understood? So select the WGS 1984, then click on OK. Okay. Then click on this OK button. Then this window will pop up. What is it telling? uh, the table you specify doesn't have an object ID or field ID. So you won't be able to select, query, or edit the feature in the resulting year. So what we have to do, this means that whatever data we are importing, it doesn't have an object ID. So to create an object ID, we have to export the data or save it in a save file format. This is what it is asking. So we'll click on OK. Okay. So all this you can see, these are our point xy data that we have collected from the field. So as it is mentioned, it doesn't have a object ID. So what we'll do, we'll export to a save file or vector file. So click on the sheet 1 or this data, right click.
Excuse me.
Yes.
Actually, one of my student, he's not getting this data in this format. Like it's scattered vertically, not like horizontal way, same as yours.
Okay, they may have
Is there
selected
any
a different
problem?
coordinate no, they may have selected a different coordinate system. So the coordinate system should be your WGS 1984. Okay. So this is the coordinate system. I'll show you. Okay, you see, go to your geographic coordinate system. Okay.
पहले सीट रिमूव कर लो, राइट क्लिक करके।
या इसको जो नहीं आ रहा है इसको रिमूव, सीट 1 को रिमूव कर लो पहले. Yeah. You go to your this geographic coordinate system first.
शेयर कर सकते हो ना, वो देखेंगे।
गूगल मीट पर।
Now it's fine, yeah.
Yeah. Okay. Okay. So that the points are coming in the desired format.
Yes, yes. Now it's fine. Huh?
Okay, so we'll export it to into a save file format. So what we'll do, just right click on this sheet 1 event, go to your data, then export data. Okay, click on this export data. Then here it will ask whether you want to export all feature or whatever features are available in the view extend. What is the meaning? We'll understand first. Suppose I have zoom into a particular area. Okay, so when I will export my data, it will ask whether you want to export all feature or all features in the view extent. So if I select this one, view extent, it will only export these few points, which I don't want. I want all my points to be exported to a particular save file. Okay, so I will select export all feature. Okay, and then it will ask for the coordinate system, in which coordinate system you want to save the layer. So I will select this layer source data. Okay, I will not select the data frame. What is the meaning of data frame? Why I am selecting this one? Because I have given a geographic coordinate system WGS 1984. I want my data to of that coordinate system. So So one more thing, whenever you are doing analysis on GIS, never use any special character or any space when you are saving it in a folder. So if I am using space between, suppose I have written bits trial and I have used an underscore, right? If I will give a space, it may not accept. It will be difficult for ArcMap to read the folder name. Okay, because it will truncate here only. So whenever you are saving it, you give a name which is continuous and don't use any special character. Just remember it. Okay. So I will select the folder and I will name it. Okay. I have selected this bit style that I have created now, and I will give a name. So I will give it groundwater, groundwater data, all point, all. Okay, you can name it groundwater all or just groundwater one will be okay. And we have to give in which type you want to save. So there are three options. First is file and personal geodatabase feature class, then save file or database feature class. So we are selecting save file, but if it is a geodatabase, do you know about geodatabase, file geodatabase or personal geodatabase? Anybody?
Database. Do you know about Geo database?
Actually,
Geo database. Geo database पता है?
Okay, I will tell you. What is a geo database? Because let's see, we are saving it into a different part. Okay, in this class, we are saving this point to a particular shape file. But if you create a geo database file, first of all, you have to create a database, personal geo database or file geo database, and you have to save all this information to a geo database. So it is very much, if you are creating a geo database, it is very much easier for your research to analyze all this data, because in a single folder or single file you can save any number of data on the database. So whenever you are going for research work, always prefer to work in a file or personal geo database. That will be much easier. But in this class, we are selecting save file because we will be working in a limited data. So I'm selecting save file. So automatically see the extension is coming .shp, groundwater 1.shp. Okay. So I will click on save, then click on OK. So it is asking, do you want to add the exported data to the map as a layer? Yes, we want the data to be exported. So you see, if I untick this event, this is my data, groundwater one data. Now you can remove this also. Set one event, you can remove it. Just left click it, then right click and remove. You can remove it. Okay, I will remove my data because I need a neater, clear environment, map environment. So I'm removing it. Set one, remove. Okay, so now I have groundwater data. Okay, so I will see what information this point has saved it. So you can click on groundwater, then go to your open attribute table. Right click, then go open your attribute table. Click on OK. See, it has all your data. You can see it has your ID, site, longitude, latitude, and your groundwater data. Okay. So whatever data information you have on your Excel sheet, now it is on map environment. Okay, if you give it this point or save file to anyone, whatever information you have on your Excel data, see he or she can analyze it or see it. So all this information, site, ID, longitude, latitude, and year, now we have on our map environment. Okay, everybody has done it.
Yes, yes,
Okay, so the next exercise, what we'll do, I want to connect. I want to have the data of 2013, or maybe it may be of 2050 or 2024 to be joined in this particular point set file. Okay, so how we'll do it? So this is my data on map environment, and you can go to your Excel file and go to your sheet 2. So on sheet 2, I have my data of groundwater table on year 2013. Okay. So I want to have this information only, that I have to join this information to my map environment so that on this attribute table I can have that information. Okay. So what I will do, how will join it? Very simple thing. You don't have to remember all these things. Very simple. Whenever you are stitching your short, or you are stitching your short, and you have to join your upper arm, left arm to your short. So what you will do, you will search for a common point, common cutting point, or common peripheral circumference. If the circumference is matching, then it must be your left hand. Okay, similarly, we'll do it on the data also. We'll search for a common ID, common point. So what is the common thing? Maybe your site. Okay. So another thing, maybe there are two village of Ajapur. First one is what? Ajapur. There may be two villages of Ajapur, or any name can be repeated on your data set. So there will be conflict. So it should be a unique ID. Okay. It should be a unique ID which will be joined our data, map data to our Excel data. So if you can see this ID that you have, this id is very unique. This id is not repeated anywhere. Okay, it's of 1 to 82. Okay, so this id is unique on both the data set. So by using this id, we have to join it. Suppose you do not have have this id, what you will do? What we'll do, we have to create a unique id. How we'll create it? We'll learn it. Okay, so how will create? Go to here. So I have to create those id on both my sheet, both my map data and my Excel data. So how will create it? I have already my unique id, but I'll show you. If you do not have id, how will create? Okay, so you go to this table option on your attribute table, click on it. You go to add field. We'll create a field first. Okay, so go to your add field, Then here I will join, I will give a name. I will give unique ID. Okay, UNID. Okay, I'll give it UNID. So the what will be the type of this field? What kind of data this field will save? So I will select text data. It will be a text data set. Then it will ask for what is the length of that data. What is the character length of the character in this text. So automatically the 50 is coming. You can truncate it to 15 or 20, or you can just keep it 50 also, not a problem. Then I will click on OK. So my one field is created here. Okay. So now I want, suppose there are two village of same name, uh, Azapur and also Azapur. On the second column there is Amirpur. Suppose that is Ajapur also. So if I join my ID and site, both the name, I will join it, then it will become a unique ID, unique name. What will be the name? One Ajapur, two Ajapur. So automatically the name will be different. So that I have to search in my data set which two three parameter that we have to join so that an unique ID can be created. Okay, that you have to think about your data set. Suppose there is a block data, uh, by village, which the village is coming under a particular block or particular district. So you can join your block name, village name, and also ID. If ID is not present, then any other thing which is different or common in both the place, you can add any number of uh, data to create a unique ID. So here, for example, I am joining ID and site. So how will join it? You just select, left click on the UniID field here. On the top of the UniID, left click it. Okay. Then right click, go to field calculator. Okay. Click on this field calculator. This pop-up will open. Just click yes. So in the on the field calculator, what we'll do, we'll join it. So how will join? I will select ID, double click it, then click on this and percent, and then click on site, double click it. Okay. So it will join the two column. So click on OK. Now see, both these column are now joined. One Ajapur, two Amirpur. Likewise, you have to create it. Okay. So in your data set, you may create this unique ID by using two, three parameter or whatever makes your data unique. Okay. So same thing we'll do it on the Excel sheet also. So on Excel sheet, what we'll do, UniID. So here, what we'll do, I will use the truncate net function. So just search for that function, truncate net, click on it, then click on ID, comma, site. This is an Excel function. Just enter it. So this ID is created now. Okay. Okay. So another thing, whenever you are creating a ID, unique ID, you just remember there should be no space or no special character. You can observe there is a special character, bracket is there, right? So whenever, or there is a space in the name. Okay. So whenever there is some this kind of space or character is there, the ArcGIS won't be able to uh, connect it. Okay. Just remember that when creating your unique ID. Okay. So this way you can create it. So in this data set we have, I will delete it, this unique ID, I'm deleting it. So I have already my unique ID over here. So we'll connect our data 2013 data by using that unique ID. This ID. So I'm removing this column also. Uh, Just click on this. If you want to remove it, just click on it and then select delete field. It will delete. Okay. Click on yes. This field will be deleted. Okay. So we'll join this data by using this ID. So I'm closing the attribute table. You may go to your groundwater data, that's save file data. Then click on it and go to your join and relate. Click on this option, fourth option, join and relates, and click on join. Okay. So it will ask, uh, what do you want to join to this layer? So there is two options, join attribute from a table or join data from another layer based on special location. So we have data on our table. So I will select from a table. Then it will ask, choose the field in this layer that the join will be based on. So my join will be based on ID. So I will select ID. Then choose the table to join to this layer or load the data from disk. So I will provide the table. I'll go to my table. You can click on this browse option and navigate. So I have my data on bits. Uh, this one, groundwater XLS. Add. It will ask which seat. If you have multiple seat, it will ask for it. So we have our data on sheet 2. Sheet 1 is of 1991. Sheet 2 we have the data of 2013. So I will select sheet 2, then click on add. Okay. Then choose the field in the table to base the join on. So which data, which ID we are selecting ID to join from the table to join to our data on our save file. So I'm clicking ID. Select keep all record because we want the whatever data on our Excel sheet to be imported to our save file. So click on this all record and click on this validate join. Don't click on OK. First validate the join, whether the join is possible or not. First validate it. Okay. So you have to see this, all these five options should be on green. Okay, if any problem is there, any space is there, or any special character is used in your Excel sheet, then the join will not be happen. It will be a failure. So you have to see all these are in green, and here you can see 82 of 82 record matched by joining. Okay. Now we can go for, we will close this window and we'll go for OK. Okay. So now click on this groundwater, open attribute table. You can see all data, whatever data we have in our Excel sheet now is imported to the save file. Okay. So this is also a temporary thing. It will be deleted once we close the ArcMaps. What we'll do, we'll save it. We'll export another point. So click on groundwater, data, then export data. Okay. Everyone is on the same platform.
Yes.
Yes, ma'am.
Okay. So we'll select all feature. Coordinate will be same as previous. This layer source data and output feature class we have to provide where we want to save it. So I will save it groundwater 2 dot shp. Okay. Okay. Then click on save. Then click on OK. It is asking to export the data. I will click on yes. Okay. Now I have my data. So longitude, latitude, year 1991, then ID again it is repeated. So I don't want it. You may delete it also. Whatever data you don't want it, you can delete it. So suppose I don't want all this data, right? I have to delete all this 5 column. So I will select one by one and I will delete field because these data are repeated. So I will delete all this field. Okay. So now I have a neater attribute table. Whenever you are working on GIS platform, keep your data very neat, very clean, so that you will not get confused after few years or month. So whenever you are doing, try to clean it at that particular time only. Okay. So we'll have, now we have 1991 groundwater data and 2013 groundwater data. If you have data of 2024, similar way you can also join it. Okay. So till now everybody is clear about it.
Yes, ma'am.
Shall we shall we move to the next question then?
Yes, ma'am.
Okay. So okay. So next is how we can plot a map. These are the data. Okay, now we have, I will remove groundwater 1 because all our data is in, now we have it on groundwater 2, so I'm removing this one. Okay, so now I have data on this table format. I want to see it on a map environment, how it is how the groundwater is varying across my area. I want to see it. So how we'll do it? I have to plot it. Like you see, these are the vector data set. So whatever data we have, suppose you can click on this identify button and go to a particular point, click it. Okay, so it will show it, so that this data point, this is the longitude, this is the latitude, and in 1991 the groundwater table is 7.71 meter, and in 2023 it goes down to 17.82 below groundwater, below the ground level BGL. So, and the fluctuation is around 10 meter. However, if I want to see a data from this place, near in between the space between these 2 points, I am unable to see it. Okay, I am unable to find what is the data, what is the groundwater of this point or the space between those points. So for that, we have to plot a continuous map, right? That is the difference between vector file and raster file. In vector file, this point is a vector file. Okay. So whatever data we have in our vector file, that is of a particular location. If you want the data of nearby location also, you will not get it. But when we convert this vector data to a raster data, we get a continuous map. Okay. We get a map like this. Okay, like this, we will get a map like this one, continuous throughout the area you will get it. But in save file you will get the information of a point only or a line only. Okay, so we'll plot a raster data set from out of this point. So what I will do, I will click on this select element option to, then I will go to geoprocessing and click on this arc toolbox. Okay, geoprocessing, then go to arc toolbox. Huh. So here select on spatial analyst tool, then go to your interpolation, select your interpolation. Okay, so in interpolation there are different kind of interpolation available. First one is inverse distance weighted average method, IDW, kriging, natural neighborhood, spline, various type of interpolation method are there. After this class you can also practice, by this data set you can also practice how the um, map is being formed by different interpolation method. Okay, so in this class we'll select one interpolation method, that is IDW. You can try the kriging and natural neighbor also. So everybody select, please select the IDW, and on this window it will ask to input the point feature. So select on it. If the point feature is already open in your arc environment, it will come from this option also. drop down option. So if it is not coming, you can select the folder option here and you can navigate to your folder where you have saved it. Okay, so I will select this one, groundwater 2. Okay, so it is asking z value. What is z value? That this is the value from which the surface will be interpolated. So automatically it is taking id, but I don't want my id to be interpolated. I want the data of groundwater data of 1991 to be interpolated. So I'll select y 1991. Okay, then it is asking output raster. So here we have to give a name. So you click on this browse option, navigate to your folder. So I will select here, I will select bits trial, and I will give name gw gw dot. It will be a raster data set, so we have to give a extension. Okay, so extension you may use img or tiff file, tiff tiff file. So here I am using img gw dot img save h type raster dataset. Okay, so just remember you have to give an extension while saving any kind of raster or vector file. So I will save it, click on save. Then there are several options also. I will go with the default, but you can always go to the help option, tool help option. You may click it. uh, Everything you need to know from this idw or spatial analyst, you will get it from the help option. So any tool on ArcGIS, you always go for help option when you are doing it for the first time, and to familiarize with the tool. So here it is asking output cell size. It is optional, but um, whenever you are working on several raster data set, you have to keep the cell size same. Suppose we you are working on landsat data. Landsat data is of 30-meter resolution, and this data, if you use it for different resolution, then when analyzing both the data set, the problem may occur. So you have to give a cell size of 30-meter or so. Okay, that is why cell size is important. But in this class, I'm keeping it optional. I'm going it by default. Then the search radius. So how it will search? This is IDW. IDW means inverse distance weighted. Means whatever data is at a higher distance, it will give low weightage. Whichever point is near to a particular point, it will give uh, higher weightage to those points. Higher the distance, lesser the point weightage. Less is the distance, higher is the weightage. So here we are searching how many numbers of point during the operation it will consider. We are selecting the default is coming 12, so I'm that is being interpolated from our data set. Okay, so this is the groundwater table data, and you can see this is the groundwater.img file that we just have created, and this is the variation of different data set. For example, the green is the groundwater data of green table is 0.725 to 2.367 meter. Okay, whereas the white, this one, if you zoom into this area, this is of 13 meter to 15 meter. Okay, so that is the beauty of GIS. You can map, you can create a beautiful map from a raw data of Excel sheet. Okay, so On the next operation, we'll learn how to clip it into a particular area. Suppose this is being interpolated for a rectangle or for the whole area, but I don't want it. I just want to analyze for my study area. So what I will do, I will extract those information to my study area. So there is a file on your folder, you can see lbmc. Okay, there is a file lbmc. So you can will clip all this information to this lbmc. So first of all, we'll open that file. To add a file to your arc
Hello, Dr.
environment, you
Sucharita.
always
Please
yes
wait
ma'am.
for a moment. Actually, some of our
Oh,
students got stuck in this field. They have not reached up to GWIMG file.
okay.
So it will take some time. Please wait for some time.
No problem, no problem, just let me know.
Actually, one of my student is getting error in creating that IDW.
Okay, can you
Then
tell me what is the error?
he is sharing his screen.
Okay.
You start your process. No? Hmm. Two times you tried. Hello.
Yes ma'am, I can see. Okay, can you show me once again how you are doing it?
Repeat the process.
Have you exported those data? No, no. I'm asking whether you have exported this. Just click on those export output. Show me the attribute table first.
Right click.
Open attribute. Okay, okay. You have this data. Okay, that's fine. Okay, just follow the IDW process. Go to your geo processing toolbox. Yes, IDW. Okay, okay. No, no, no. You are saving it in your default database. You just save it to your location. Connect to the folder. No, you save it in the bits file because in bits Sindri there is a space in the folder. No, no, don't select the new folder because there is a space in the name. So you have to remember whenever you are doing any ArcGIS operation, there should not be any special character or space in the name of the folder.
नहीं वो मिल रहा
You
है
can select the bits one.
स्पेस नहीं होना चाहिए इसके अंदर.
Yes, space. You can select the bits. Yes. Okay, click on OK. Okay. No, give a name first. Okay. But why it is showing default? No, no, no. The C drive, you select once again. The output raster, you just select once again.
अच्छा ब्राउज कनेक्ट टू फोल्डर हो रहा है. ब्राउज में एक बार जाओ. हाँ इधर से. हाँ आया.
Okay. Save it. Okay. Click on OK. Okay. Fine. So you understand the problem, right? Whenever there is a space or special character, ArcMap will stop responding. Okay. Okay. So shall we move to the Next one.
Ha ha. Yes, yes, yes.
Okay. Let me share my screen. Okay. Um, so you may open your LBMC file, that is a save file of your area, which we want to analyze. So you click on this add data, or you can go to your file, then add data. Anywhere you will get it. If it is the option is coming on this one, on this tab, you can click on this add data directly, or you may go to your file, click on add data, and click on add data. Okay, so you navigate to your folder. So I have saved this on your on my bits folder. So I will navigate to my folder, then select lbmc.shp. So click on this file lbmc.shp and click on add. Okay, so everybody is on the same platform. Okay, so I hope we are on the same platform. Now we have data of groundwater table for the whole area, but we want to extract it for our area. Okay, so how we'll do it? We don't need all these points. These are unnecessary for us, right? So we want it for our area. So what I'll do, I will extract it. So go to your
Excuse me, ma'am.
geotable. Yes.
Ma'am, please once repeat again the LBMC process.
Okay, you have opened your LBMC file.
No, ma'am.
Okay, just I'm removing it. You go to your add data file, then add data. Click on this add data option, first one, this plus sign. Click on this add data and navigate to the bits folder where your raw data is given to you. Just navigate it and select the lbmc.shp. Okay, click on this file and then click on add. Okay, it will appear on your screen. Okay, are you on the same platform or shall I wait?
Yes, ma'am.
Okay, okay. So now we'll do extraction of the groundwater raster data to our area. So how we'll do it? You go to your geoprocessing, then navigate to arc toolbox, and here and go to your spatial analysis tool, and there is an option toolbox called extraction. Okay, just click on this plus sign. Okay, and then select how it will show option of different type, how you want to extract by attribute, extract by
Hello,
single
Dr.
row.
Sucharita.
Yes, ma'am.
Actually, student is not able to add LBMC properly. It's not visible in the interface actually. He is
Okay,
adding.
okay, shall I my screen is visible, right? Or shall
Your
I
screen is visible, huh?
okay,
But
okay,
once again,
okay, I'm
can you
okay, I will
share?
remove it and I will again add it. Okay, so you have to go to your file. Likewise, you have done your XY coordinate. Okay, so go to your file, click on add data, and click on this add data file, first one. Okay, just select this option. Is it visible?
Yes, ma'am.
Okay, click on this add data, then navigate to your folder where you have your data, groundwater data that I have provided. You navigate to that folder, bits folder. Okay, these three are visible: block, desire, groundwater, and LBMC. These are visible.
Yes, ma'am.
Yes, yes.
Okay. Now select the lbmc.shp. Okay. Just one click. lbmc.shp and click on add. Okay, so the vector file, the polygon file will appear on your screen. Okay,
Okay, ma'am. Yes.
now it
Okay,
is
okay.
okay.
Hmm.
Okay, so we'll go for extraction now. So what we'll do, we'll go to your geoprocessing tool, click on this, go to your arc toolbox, then go to your spatial analyst tool. Okay, there is an option spatial analyst tool, and go to your extraction, this one, extraction, click on this plus sign, and then it will ask how you want to extract the data. Suppose we'll first understand what are the options available and what we should select. So it is asking extract by attribute, whether you want to extract by a attribute table or by a circle or by mask or by point. So we'll mask it. We'll select extract by mask because uh, because whatever data we have on a raster format, that will be extracted by a save file only by a mask. If you are if you have a polygon file or a save line file, you can select. If it is a circle, you can select circle. If you have point data set, you can go for point. But I have a the save file format. I have a complete polygon file of complete data. So I will mask it. Whatever data we have, I will mask it. So click on this extract by mask, double click it, extract by mask. Okay, then this option will pop up. Go to input, you have to provide an input raster file. So on the drop down, already there is gw.img. If it is not there, you can always browse from your folder. Okay, so I'm selecting gw.img, then input raster or feature mask data. So here it will ask to provide a feature data set. Here you can give a raster data set also. Suppose you have a raster data set of land use land cover file of a particular area. You want the groundwater data of that area only. You can always give a mask. On mask data, we can always use raster or feature data set. So I'm selecting LBMC, input raster or feature data is my LBMC. Then the third option is we have to provide a location. So click on your browse option and navigate to your folder where we are saving it. So I'm saving it in bits trial. So I will name it GW LBMC. Okay, it will be easier for me to remember GW LBMC, and the extension is .img. Okay, GW LBMC .img. Then click on save. Okay, now all these three options are filled up. Now I will click on OK and wait for a few seconds, and this is done. Okay, so now I will uncheck it, the groundwater.img file, and I will also uncheck this one, lbmc. See, this is my ground gw lbmc.img. Okay, so you may ask that why it is a continuous color, why not it is a classified. Okay, if you want to change it to this kind of classified data, how we'll do it? Click on this GWLBMC and go to the properties. Okay, so on the properties, you go to your symbology, and here it is stretched. The on default is stretched. We have to select the classified. Okay, upon classified, you can use any color ramp. So I'm using suppose this one. You can use any of your choice. Click on apply. Okay, so the color is changed to this one. Okay, everybody is on same platform, or shall I wait?
Yes, we are on the same platform.
Okay, okay, ma'am. So one more thing. Suppose here there is an option to classify. Here we have five division. but I want my data to be divided into three parts, three division. Okay, because or for any reason, if you want to signify a particular class, then you can also classify it by using this option. Okay, suppose I want to classify, I want to give higher importance to those area which have a groundwater table data of 1 to 3 meter. Okay, so how will do it? These are the default classification. So but I want mine to be customized. So what I'll do, I will change the break value. I will give it 3. First one is up to 3 meter, then you can give 4 meter. Likewise you can change it. Okay, or this is 6.5, or last one is okay, last one I will truncate it to 8.4 or something. Okay, so click on OK. Now the data is changed, right? 1 to 1 to 1.4 to 3 meter. So in this label also, this is the range and this one is the label. You can always edit the label. Suppose I want to say it, so it 1.4 to 3, and I want to remove this 001. So I can remove it also. Okay, this will give us a very neater look. Okay, okay. Likewise, I can change the level also. I can focus to those area of my requirement. Suppose you are analyzing a area where the water table is going below very drastically. So you want to emphasize those area. So how will do it? You have to classify a particular groundwater data set to your requirement. Suppose you want to focus the groundwater table where it is below 20 meter or 30 meter, so you can classify it and prioritize those area. So this is how it is done. You can click on apply and click on OK. So now the map is ready. I will remove this gw.img file because I don't need any longer. Okay, so another thing we'll learn, um, suppose this is for my lbmc. Okay, so you can always customize how this line will look like. Suppose the field color of lbmc is blue color, but I want to see what's behind it. So what I will do, I just click on this lbmc file, and I can choose this hollow option. Okay, and I can give a outline width of higher value. Suppose it is 2, then I can see. Now see, this is our boundary, and this is the groundwater variation within our study area. Okay, this is how it is, a map is formulated. Okay, another thing we'll learn. Uh, Komal ma'am, can I continue?
Yes, just explain them how to like complete a map with direction and all
Yes,
symbols
yes,
need to.
I'll show it. I'll show it. Okay, okay. So, okay, this is the groundwater variation of our area. So I want to build a map on it. So how will do it? This is the data frame view. You can see there are two view on the left side of the arc map. First is data view and another is layout view. So for mapping, you have to select the layout view where you can lay out a particular view. So select on layout view. So this boundary will come, this layout will come. So you can zoom into this area. For zoom in, you have to select this one, full extent, or you can select this one also. Fixed zoom in or zoom out option is there. So I'll select full extent. Okay, so I can zoom, I think I can zoom in a little bit. Okay, okay. So I want my map to be positioned on the center. So I will drag it. You can use the pan option. Click on pan, and okay, now it is on the center. So now I will give some coordinate system to our map. To give coordinate system, you have to select the inner boundary. Then click on this inner boundary and go to your properties. Okay. select your properties. Okay, go to your new grid, then select the graticule, divide the map to meridians and parallel. Click on next.
Dr. Pradhan, uh,
Yes.
last step, how to make this grid thing? They want its repetition once again, please.
Okay. Let me
Huh.
close it. Okay. So you have to select the inner boundary, then click on
How to create this layout part?
okay, you
Want it?
have to select this option. First, the data is on your okay. Here you are in the data view,
Yes.
right?
Huh.
You have to select the layout view. Okay, that is the layout view. This one near to it. Okay,
It's fine. Huh. Layout view.
layout view. So I have already set up my map to the center. If you haven't, you can use this pan option or full extend option. Full extend means whatever data we have, why it is coming to the left side, because on our arc environment there is a groundwater data. This point data are also there, right? That's why it's coming to accommodate all this information. The map is going to our right side, but if you do not want that, you can also remove it. Or if you do not want this data and you want your map to be on the center, you can use this zoom in option, zoom in a little bit, then go to your pan to bring the map to a center. Okay. If there is space remaining, you can always zoom in. Okay, till your requirement. I think this part is coming to our left side, so I will zoom out a little bit. Okay, I think this is great. So okay, now we'll assign a coordinate system to our map. So what I'll do, we are in now in pan option, right? So we have to select it to select element option. Click on select element, click on this option, click on the inner boundary. Okay, then go to properties. Okay, so in data frame properties, click on this new grid. Okay, new grid, select the graticule and click on next. So here it is coming appearance, how you want your map to be appear. First one is label only. Label means the longitude and latitude will only come on the boundary side, and on the second option, tick mark and label. Uh, this the map will appear like this. Okay, there is a tick mark inside the layer also, and the label outside, and this is graticule. Okay, so I want my map to be very neater look because I want information inside the map. So I will select label only option, then go to your interval. On interval, you have to select in how much interval you want to place the latitude and longitude. So the degree, it is in 1 degree by 1 degree. 1 degree is very too high for a small area. So I will select 0, but the minute should be 30-minute interval. If you are working on India scale or larger state scale, you can always go for 1 degree by 1 degree or 2 degree based on your requirement. Okay, or if your area is very small, you can also go for seconds. Okay, you are analyzing for 100 meter by 100 meter plot, or 500 by 500. You can the minute will be very much same, so you can go for second variations. So here the area is 5000 kilometer square area, so I think 30-minute interval will be better. Okay, then click on next, then I'll click on next. then I'll click on finish, and I'll apply, click on this apply button. Okay, now you can see uh, the latitude and longitude are appearing outside of the boundary, but it is not visible, right? So I want my latitude and longitude to be visible. So I would enhance the size of that latitude and longitude. So to change anything, if any parameter you want to change on your map, you can go to properties. On the data frame properties, go to your properties. Okay, so here there is an option, what will be the font size. So I will select, let's suppose this is Arial, I will select a size of like 18 or something. Let me select 16, and I want my latitude longitude to be in bold, so I will select bold option. And what else, I want my this longitude latitude to be on a horizontal vertical level. That orientation I want it in a vertical plane, because it is coming outside the boundary and it's not looking good also. So I want to flip it to a vertical direction. So what else, click this label orientation of left side and right side should be vertical. So I will click on left and also on right, then I will click on apply. Okay, and click on OK, then click apply here. Now it's something better, right? Okay, so if you want to change it to like, you can see there is some space remaining. No, I can add another latitude or longitude label also. So I will change the, okay, so here I can change the interval also. Um, Previously we have given 30 meter by 30 meter, 30 minute by 30 minute interval. Let me change it to 20 minute. 20 minute on x-axis and 20 minute on y-axis, and see how it is happening. Click on apply. So now I have 5 or 6 label on the vertical direction and 4 on the horizontal direction. I think it's now it is complete and looking good also. I will click on OK, and see you can also move this line also if you want it to in a very much near to the map. You can always move it as per your requirement. Okay, okay, now we'll add some map element to it, because we don't know what is the north direction, what is the scale of the map, what is the name of the map, we don't know anything. So these are the element that is required for map preparation. So you go to insert option on your tab, and go to title. Okay, and here you can give a title. I'm naming it as a groundwater map. Groundwater groundwater map. Okay, okay, then I will insert a north arrow. So again I will go to insert and click on this north arrow, and any arrow you can choose. I can select I'm selecting the first one. Click on OK, and this is how it comes. So I will extend it, and I will bring it to the right top side of the map. Okay, then what else, we have to insert a scale. What is the scale of the map? Okay, go to your insert, then click on the scale bar. Okay, so I'll select this one, and this is in mile, so I don't want it to be in mile, I want it to in meter or kilometer. So what I'll do, after selecting a particular scale, you go to the properties, then here you can divide it also. By default the number of division is 4 and subdivision is 4. I'm okay with it. If you want it to in different divisions or 3 division or more number of divisions, then you can add it 5, 6 or anything you want it. Then come to the division unit. What is the unit of the division? I want it in kilometer. Okay. So then label position, where the kilometer, it will be written, kilometer will be written. So where it will be, after the bar or above the bar, below the bar, anything you can choose. So I want it after the bar. So I'm selecting after bar. Okay. Then label also you can select, you can write anything. The kilometer K is capital, so I'm removing it. I can write, I'm writing K in small letter, kilometers. Or the, or symbols also you can choose. I want it in Times New Roman or Arial. You can select this one format also. Okay, so I want my letter to be in Times New Roman. So I can select from this one, I can select Times New Roman. Size I want it 14 and bold. Okay, this is how you have to edit as per your requirement. Okay, then click on apply. Okay, then click on OK. Okay, so this is how it comes. I will extend it to, the division is 4 division. Uh, that's why I'm extending it. For a neater look. Okay, so this is my scale. Okay, then what else? We don't know what the colors signify. What is the meaning of this green color or red color? We want to label it. So how it will be done? How the labeling will be done? So what I'll do, I will click on this. um, no, no, I you have to go to insert again. Then there you have to select label, legend. We go to legend. Okay, so here in the legend wizard, you can select, you can see that there is 3 map layer, and these are the legend item, lbmc, gw, lbmc.img. So if you want, if your data frame has n number of data, it will appear on the map layer, and whichever data you want to be on your legend item, you can add it. How? Just I want it groundwater 2 to be on my legend item. So what I will do, I will select it groundwater 2, then I will click on this option. Okay, now it comes under legend item. Okay, if you want to remove anything, suppose I am removing this groundwater 2, just click on it and click on this button, so it will be removed. Okay, likewise, so I want this two legend, lbmc and groundwater lbmc.img. Then I'll click on next. Okay, so click on next and next and finish. So the now the legend is created. Okay, so I don't want my value to be written here, or this greater than or less than symbol. So what I will do, I will edit it. I can click on this button and I can remove this one. Okay, this is how it looks like. And this image, groundwater lbmc.img, is the name of that layer, but I want it to be written that groundwater level below ground level. So what I do, I will edit it. This name, just double click it, and you can edit it right here also. Groundwater bracket bgl. Okay, so whatever changes you have done on this table of content, it will be reflected on your map. Okay, then another thing, this is the lbmc. I want it to be a watershed boundary, so I will write it watershed boundary. Okay, now it has changed. So this is how you create a map or you can always go for customization. And for customization, if you want to change this legend item, you just click on this, go to properties. Okay, so here, suppose I want, you can observe that this is in Arial, but I want it in Times New Roman. How I will do it? I will select all. I'll select both the layer. Then I'll choose Times New Roman from here. Okay, and I want it in 18. The font size would be 18. Bold. Apply. So now this value is changed. The font size is changed, right? So if you want this, however, this legend font is not changed. So to change that, you have to go to the title legend, or and then click on this symbol item. Okay, from symbol you can change it to Times New Roman or anything you want it to be. Click on OK, apply. Okay. Okay. Now you have your north arrow, your title, your legend of this map, and your scale of the map. Now I want it to be exported to a JPG format so that I can take a printout and go to my area of study. So how I'll do it? How I can take a printout? Just go to your file option, then click on export map. Okay. So here I will save it. Um, Router map .jpg. You can also enhance the resolution. I'm keeping it in 200 dpi. Wherever you, if you want to uh, print it on a A0 size paper or a big map, you can always enhance into 600 dpi or 300 dpi. It will enhance the resolution. Okay, so click on save and the map will be exported. So let's see how it comes. I'll go to my folder, and this is the map of groundwater table that we just have created. Okay. Any doubt on this?
Thank you, Dr. Sucharita. I doubt because you have explained it in a quite smooth way. So thanks a lot. It was
Still, many things are left out because I want to also
yeah,
show how.
ARCGIS is
Yes,
that only
right,
after learning.
right.
Lots of things are there. It will take time, but
Yes.
still
One
today's
more.
session was quite productive. Yeah, you are.
Thank you, ma'am.
So what you are telling something, na?
Yes, the Google Earth person is left out because that is also an important part. How you can draw some feature on the Google Earth and how we can import it into our Earth environment. So that is also important. But maybe next time we can.
Anyways, thank you. We will see if we will have time in this workshop only. Then we will again connect to you. We'll try.
Sure, sure,
Our students
sure.
got quite benefited with this session. They are quite excited
Thank
to
you.
meet you once again. We'll try. And thanks a lot for
And
this.
thank you.
Thanks a lot, Doctor.
Thank you. Thank you so much.
Thank you, ma'am, for sharing such valuable insights. Water shed planning and management are critical areas, and your expertise
It's okay. It's okay.